Alright guys, welcome back. So now let us discuss nomenclature of coordination compound. So for easy comprehension, you should know neutral, ionic and cationic ligands. For neutral ligands, we have ammonia, right, which is called ammonio. And then we have NO, which is nitrosyl, water is aqua, CO is carbonyl, and then CS is thiocarbonyl. We have also the anionic ligands. These are chloro, bromo, hydroxo, and the rest. Then we also, among these, we have SN minus, right? Cyanide, so which means cyano. So we have also cationic ligands. We have nitrosonium, and then we have nitronium. Then we have hydrozinium, NH2, NH3+. Then remember this, ammonium, it has positive, right? But it is not a ligand because it cannot donate a lone pair of electron. So I hope you are going to note this point. Alright, welcome back. So now let us begin with nomenclature of coordination compound. The first step, if you are given a coordination compound to name, the first thing to do is to find the oxidation state of the central metal atom. So in this case, silver, Ag, is our central metal atom, right? So therefore we have Ag plus, we have NH3. NH3 is neutral, right? It equals to 0. It is oxidation number equals 0, but it has 2, right? So we say 2 into 0 plus into minus, right, 1, which is Cl. The oxidation number of chlorine is minus 1. Then equals 0, because if you can see, this coordination compound is neutral. All of it is neutral. It has no any charge, neither negative nor positive, right? So therefore it is oxidation number equals 0. So now plus 2, right, minus plus 2 minus 1 will give us minus 1 equals 0. So crossing this minus 1 to this side, we are going to have Ag equals plus 1. So the next thing to do is then to come and name each of the given element in the compound. So the first thing to do is to identify the ligand. Our ligand is ammonia, right? But it has 2, right? Then we say diammonia. Do you understand this? Then we have the central metal atom attached to it, which is silver. Then we say diammonia silver 1, which is the oxidation number of this silver. And then finally the cationic, right, which is chloride. Sorry, the anionic ligand, which is chloride. So diammonia silver 1 chloride is the name of this compound. And then as you can see, we just put on chloride without adding any suffix. So this is because if you can see these coordination sphere, right, it has positive charge. It has positive charge because the counter ion is negative. I hope you understand this. So now let us see another example. We have this coordination compound K2 into NiCl4. So the central metal atom is nickel, right, Ni. So then we say 2K, right, plus Ni plus 4Cn. I hope you understand this because this Cl has what? This is Cl. It has what? This is not Cn, is Cl. It has 4 equals 0 because this coordination compound is neutral, right? And then we are going to have 2 right into 1 because potassium is plus 1. Then nickel, which we are looking after, it is oxidation number 4 into minus 1, which is chlorine, oxidation number equals 0, right? So this will give us plus 2 minus 4, right? Then equals 0. So therefore plus 2 minus 4 is minus 2, right? So equals 0. So therefore nickel equals plus 2. So now then we are going to name it. So to name this, the first thing to do is to begin from the left, right? Because we have a positive metal from the left. The counter ion is positive. So therefore we say potassium, right, which is this. And then we have our ligand is chlorine, then we say chloro. However, it has 4, then tetrachloro, right? Then our central metal, which is nickel. So in this case, you can see we have added ATE. This is because the coordination pair, it has negative here. That's why the counter ion here is positive, right, which neutralize the effect of this coordination pair. I hope you understand this. So once the coordination pair is negative, then you are going to add ATE as a suffix to the central metal atom. Do you understand this? So therefore the name of this is potassium tetrachloronickelate 2, where 2 is the oxidation number. So now let us see this. This is a complex ion, right? So in this coordination compound, we are to find the oxidation number first of the central metal atom, which is this ion Fe, right? So you have Fe plus 6 into minus 1, because this is fluorine. F, it has -1, which is fluoro, right, equals -4. You see, because this coordination pair has -4, so therefore Fe, right, this time this will give us -6 equals -4. Therefore -6 plus 6 -4 plus 6 equals +2. The oxidation number of Fe is +2. So therefore now we are going to name it. Then we are going to say we have ligand, which is fluoro, right, but it has 6, right? So hexa fluoro. Then we have ferrite. Remember why we added this ATE, because the coordination pair has a net charge of negative, right? It has negative on it. Do you understand this? That's why you added ATE. So then ferrite 2 ion, because it is a complex ion, right? That's why we say ion. Do you understand the hexafluoroferrate 2 ion? I hope you understand this. Then finally we are going to, okay, then this is second to the last. So in this case, we are having this compound, we are to name it. So the central metal atom is in red color, right, which is this chromium. So we have Cr plus into plus 4, right, into 0, because water is 0, right? Then plus 2 into -1, because chlorine is what, is -1. Then also plus 2, right? Sorry, then plus -1. Then plus -1, because NO3 minus, this oxidation number is -1. Do you understand this? So therefore equals 0, because the compound has no net charge, neither positive nor negative. I hope you understand this. So now calculating everything, we are going to have chromium equals +3, right? So this is the oxidation number. Then the second step is now to name it. So in this case, we have to follow alphabetical order, because we have 2 ligands inside, right? So therefore the first one, we have water, which is aqua, and chloro, right, chlorine. So A comes, then C, right? So therefore you start with A. So we say tetra, because water has 4, tetra aqua. Then di, because it has 2, right, dichloro. Then our central metal atom chromium, it is oxidation number 3, chromium 3. Then nitrate, because this is the nitrate, right? And then it is an ionic ligand, so it has to come last. Do you an ionic counter, sorry, this here counter, and it has to come last. It is an ionic ligand, so it has to come last. Do you understand this? All right, so we have tetra aqua dichloro chromium 3 nitrate, and you can see in the chromium we didn't add any suffix, because the net charge of this, of the coordination sphere, if you remove this negative NO3, this NO3 is negative, right? So then the coordination sphere, it has a positive nature, so therefore you cannot add any ATE. I hope you understand this. Finally, we have this compound. So in this compound, we are to name it. So to name this compound, we have to find the oxidation number of the central metal atom, right? But before then, remember, when you see En equals ethane 1,2-diamine. Do you understand this? Yes. So now ethane 1,2-diamine, when you are to write it, this is it is condensed formula, right? So now we have CO plus this En, it has 2, right, into this, then plus 2 Cl plus Cl equals 0, right? So now we are going to have En 2 into 0, right? It has 2, so it has 2, then this compound is neutral, you can see, so it's 0, right? Plus 2 into minus 1, chlorine is minus 1, plus minus 1 equals 0. So calculating everything, we get after we get cobalt is what? Is plus 3. Do you understand this? So now the naming. So to name this, we are going to also follow from the left to the right. So what we do is we have now our chlorine. The first chlorine is the ligand, right? Because chlorine comes before E. C comes before E, right? You have to follow alphabetical order. So now we have our chloro. However, it has 2, right? The chlorine has 2. Then we say dichloro, right? Then we have diethane. So in this case, you cannot say di, you have to use bis. Why? Because it is already having di inside, so you cannot say by ethane 1,2. You cannot say diethane 1,2-diamine. No, you say bis ethane 1,2-diamine. Then we have this cobalt, right? Cobalt, then cobalt 3 chloride. So you can see, because this coordination sphere has what? Negative, net negative. Okay, net positive, because the counter ion on it is negative, right? So therefore you cannot add ATE. So dichloro bis ethane 1,2-diamine cobalt 3 chloride. I hope you understand this. So in case, if let's say we have propan 1,2,3 triamine, so here you use threes. Do you understand this? Like this. Thank you very much. I wish you all the best.